Welcome to my channel. Today, I will whisper to you about Albert Einstein, one of the greatest minds in the history of science. We will explore his life, his groundbreaking theories, and the profound impact he had on our understanding of the universe. Let's begin this fascinating journey. Albert Einstein was born on March 14, 1879, in the city of Ulm in the Kingdom of Württemberg, which was part of the German Empire. His family was of Jewish descent, and his father, Hermann Einstein, was an engineer and a salesman, while his mother, Pauline Koch, was a housewife. Einstein had one sister, Maria, who was affectionately called Maya. From an early age, Einstein showed signs of curiosity and intellectual ability. However, he did not speak until he was around 4 years old, leading his parents to worry about his development. Einstein's early education was characterized by his struggles with the rigid and authoritarian schooling system of the time. He attended a Catholic elementary school in Munich, where his family had moved shortly after his birth. Later, he transferred to the Leopold Gymnasium, where he received a more advanced education. Despite his aversion to the rote learning methods and strict discipline, Einstein excelled in mathematics and physics. He often taught himself advanced concepts beyond his school curriculum, displaying an insatiable curiosity and a profound love for learning. At the age of 15, Einstein's life took a significant turn when his family moved to Italy due to business difficulties. He stayed behind to finish his education, but soon left the gymnasium and joined his family in Italy. This period of transition allowed him to reflect on his future and develop his independent thinking. He decided to pursue higher education in Switzerland, a country known for its more liberal and progressive educational institutions. Einstein enrolled in the Aargau Cantonal School in Aarau, Switzerland, to complete his secondary education, where he thrived in a supportive and less authoritarian environment. In 1896, Einstein enrolled in the Swiss Federal Polytechnic in Zurich, a prestigious technical university. He initially aimed to become a teacher in physics and mathematics. During his time at the Polytechnic, Einstein formed important friendships and connections, including with Marcel Grossmann, a fellow student who would later help him secure a job at the Swiss Patent Office. It was also in Zurich that Einstein met Mileva Merrick, a fellow physics student who would become his first wife. Their relationship was both intellectually and emotionally significant, with Mileva often engaging in discussions about scientific ideas with Einstein. Einstein graduated in 1900 with a diploma in teaching but struggled to find a permanent academic position. He took on various tutoring jobs and eventually secured a position at the Swiss Patent Office in Bern in 1902. This job provided him with a stable income and ample time to ponder scientific questions. It was during his time at the Patent Office that Einstein began to develop some of his most revolutionary ideas. The environment at the Patent Office, where he reviewed patent applications for new inventions, exposed him to a wide range of technical problems and innovative ideas, which stimulated his own thinking. The year 1905, often referred to as Einstein's Annus Mirabilis or miracle year, was a turning point in his career and in the history of physics. In that year, Einstein published 4 groundbreaking papers in the Annalen der Physik, a leading scientific journal. These papers would change the course of modern physics and establish Einstein as a prominent figure in the scientific community. The first paper, published in March 1905, was titled On a Heuristic Viewpoint Concerning the Production and Transformation of Light. In this paper, Einstein proposed the idea that light could be understood as discrete packets of energy, which he called quanta. This concept, known as the photon theory of light, explained the photoelectric effect, a phenomenon where light striking a metal surface produces an electric current. Einstein's explanation of the photoelectric effect provided crucial evidence for the emerging field of quantum mechanics and earned him the Nobel Prize in Physics in 1921. This work was pivotal because it challenged the classical wave theory of light and laid the foundation for the development of quantum theory. The second paper, published in April 1905, was titled On the Motion of Small Particles Suspended in Stationary Liquids Required by the Molecular Kinetic Theory of Heat. This paper provided a theoretical explanation for Brownian motion, the random movement of microscopic particles in a fluid. Einstein's work confirmed the existence of atoms and molecules, which were still debated by some scientists at the time, and provided empirical support for the kinetic theory of heat. By explaining Brownian motion through statistical mechanics, Einstein's work offered compelling evidence for the reality of atoms and molecules, thus solidifying the atomic theory of matter. The third paper, published in June 1905, was titled On the Electrodynamics of Moving Bodies. This paper introduced the special theory of relativity, a groundbreaking concept that revolutionized the understanding of space and time. Einstein proposed that the laws of physics are the same for all non-accelerating observers and that the speed of light is constant regardless of the motion of the light source. This led to the famous equation E equals mc squared, which established the relationship between energy, E, mass, m, and the speed of light, c. The implications of special relativity challenged the classical notions of absolute time and space, fundamentally altering the field of physics. Special relativity showed that time and space are intertwined and relative to the observer, leading to profound implications for our understanding of the universe. The fourth paper, published in September 1905, was titled Does the Inertia of a Body Depend Upon Its Energy Content? This brief paper further explored the implications of the special theory of relativity, introducing the idea that mass and energy are interchangeable. This concept, encapsulated in the equation E equals mc squared, would later play a crucial role in the development of nuclear energy and atomic weapons. This insight revealed that even a small amount of mass could be converted into a significant amount of energy, a principle that underpins both the destructive power of nuclear weapons and the potential for nuclear energy. Einstein's 1905 papers marked the beginning of a new era in physics. His innovative ideas challenged the established scientific paradigms and opened up new avenues of research. Despite the initial skepticism from some members of the scientific community, Einstein's theories gradually gained acceptance and recognition. His work attracted the attention of leading physicists, and he began to receive invitations to speak at prestigious academic institutions. The fourth paper, published in September 1905, was titled Does the Inertia of a Body Depend Upon Its Energy Content? This brief paper further explored the implications of the special theory of relativity, introducing the idea that mass and energy are interchangeable. This concept, encapsulated in the equation E equals mc squared, would later play a crucial role in the development of nuclear energy and atomic weapons. This insight revealed that even a small amount of mass could be converted into a significant amount of energy, a principle that underpins both the destructive power of nuclear weapons and the potential for nuclear energy. Einstein's 1905 papers marked the beginning of a new era in physics. His innovative ideas challenged the established scientific paradigms and opened up new avenues of research. Despite the initial skepticism from some members of the scientific community, Einstein's theories gradually gained acceptance and recognition. His work attracted the attention of leading physicists, and he began to receive invitations to speak at prestigious academic institutions. In 1909, Einstein left the Swiss Patent Office to accept a position as an associate professor at the University of Zurich. His academic career continued to flourish, and he held various teaching and research positions across Europe, including at the universities of Prague and Berlin. In 1914, he became a professor at the Humboldt University of Berlin and a member of the Prussian Academy of Sciences. During this period, Einstein continued to develop his ideas, culminating in the publication of his general theory of relativity in 1915. The general theory of relativity was a monumental achievement that revolutionized the field of physics. One of the key predictions of the theory was the bending of light by gravity, known as gravitational lensing. This phenomenon was confirmed during the solar eclipse of 1919, when observations made by Sir Arthur Eddington and his team showed that light from stars passing near the sun was deflected, as predicted by Einstein's equations. This empirical validation brought Einstein international fame and established him as one of the foremost scientists of his time. Einstein's work during this period also contributed to the development of cosmology. His equations suggested that the universe could not be static but must either be expanding or contracting. Initially, Einstein introduced a cosmological constant, a term in his equations that allowed for a static universe, which he later referred to as his greatest blunder after the discovery of the universe's expansion by Edwin Hubble in the 1920s. The concept of an expanding universe laid the groundwork for the Big Bang theory, which describes the origins of the cosmos. Throughout his career, Einstein's contributions to science were not limited to theoretical physics. He was also an advocate for social justice, peace, and human rights. As a prominent public figure, he used his platform to speak out on various issues. In the 1920s and 1930s, Einstein became increasingly vocal about the rise of nationalism and militarism in Europe. He was a strong opponent of the Nazi regime in Germany and, being of Jewish descent, faced significant personal risk. In 1933, with the rise of Adolf Hitler to power, Einstein emigrated to the United States and accepted a position at the Institute for Advanced Study in Princeton, New Jersey. Einstein's time in the United States was marked by continued scientific work and public advocacy. During World War II, he was a member of the Emergency Committee of Atomic Scientists, an organization that sought to promote the peaceful use of atomic energy and prevent nuclear proliferation. Although Einstein did not directly work on the Manhattan Project, his famous letter to President Franklin D. Roosevelt in 1939, co-signed with physicist Leo Szilard, alerted the U.S. government to the potential for Nazi Germany to develop atomic weapons and ultimately led to the initiation of the project. In the post-war years, Einstein became an outspoken advocate for disarmament and international cooperation. He was a founding member of the Bulletin of the Atomic Scientists, a publication that highlighted the dangers of nuclear weapons and the need for global dialogue on arms control. Einstein's commitment to peace and humanitarian causes earned him admiration and respect beyond the scientific community. Despite his achievements and fame, Einstein remained humble and introspective. He often reflected on the nature of his work and its implications for humanity. He once said, "I have no special talent. I am only passionately curious." This curiosity drove him to explore the fundamental questions of the universe and to seek answers that would expand the boundaries of human knowledge. Einstein's legacy extends far beyond his scientific contributions. His theories have had a lasting impact on various fields, including physics, cosmology, and technology. The principles of relativity have influenced the development of technologies such as GPS, which relies on precise time measurements that account for the effects of both special and general relativity. Quantum mechanics, a field that Einstein helped to pioneer, continues to drive advancements in computing, communication, and materials science. Einstein's life and work also serve as a testament to the power of intellectual curiosity and the pursuit of knowledge. His willingness to challenge established ideas and to think deeply about the fundamental nature of reality has inspired generations of scientists and thinkers. His contributions to science and society have left an indelible mark on the world, making him one of the most iconic figures of the 20th century. Einstein's influence extended into the realm of education and public understanding of science. He believed in the importance of making scientific knowledge accessible and understandable to the general public. Throughout his career, he wrote numerous books and articles aimed at explaining complex scientific concepts in a way that could be appreciated by non-experts. His book Relativity, the Special and the General Theory, published in 1916, was one such effort to demystify his groundbreaking theories. In addition to his public writings, Einstein's lectures and public appearances drew large audiences and generated widespread interest in science. He was known for his ability to communicate profound ideas with clarity and simplicity. His lectures at universities and scientific conferences around the world were often packed with eager listeners, ranging from fellow scientists to curious lay people. Einstein's approach to science was characterized by a deep sense of wonder and a relentless pursuit of truth. He once remarked, "The important thing is not to stop questioning. Curiosity has its own reason for existing." This philosophy guided his work and inspired others to explore the mysteries of the universe with the same fervor. Despite his many accolades and achievements, Einstein remained a humble and unassuming individual. He often downplayed his own contributions, attributing his success to a combination of curiosity, perseverance, and a willingness to learn from mistakes. He was known for his modesty and his ability to find joy in the simple pleasures of life, such as playing the violin or sailing. Einstein's personal life, while often overshadowed by his scientific achievements, was also marked by significant relationships and experiences. His marriage to Mileva Merrick, whom he met during his studies in Zurich, was both intellectually and emotionally significant. They had 2 sons, Hans Albert and Eduard. However, their marriage faced challenges, and they eventually divorced in 1919. Later that same year, Einstein married his cousin Elsa Lowenthal, who provided him with support and companionship until her death in 1936. Throughout his life, Einstein maintained strong connections with other prominent scientists and intellectuals. He corresponded with leading figures such as Max Planck, Niels Bohr, and Sigmund Freud, engaging in discussions that span a wide range of scientific and philosophical topics. These interactions enriched his understanding and often influenced his own work. As he grew older, Einstein continued to be a vocal advocate for social and political causes. He was a committed pacifist and a strong supporter of civil rights. He was particularly concerned with the plight of African Americans and spoke out against racial segregation and discrimination in the United States. In 1946, he joined the NAACP and worked alongside civil rights leaders such as W.E.B. Du Bois to promote equality and justice. Einstein's later years were also marked by his reflections on the role of science in society. He was deeply concerned about the ethical implications of scientific advancements, particularly in the context of nuclear weapons. He famously stated, "The unleashed power of the atom has changed everything save our modes of thinking, and thus we drift toward unparalleled catastrophe." This sentiment underscored his commitment to using scientific knowledge for the betterment of humanity and his advocacy for international cooperation and peace. Einstein passed away on April 18, 1955, at the age of 76, in Princeton, New Jersey. His death marked the end of an era, but his legacy continues to resonate deeply within both the scientific community and the broader public. The world mourned the loss of a brilliant mind, and tributes poured in from all corners of the globe, highlighting the profound impact Einstein had on science, philosophy, and human thought. Today, Albert Einstein's name is synonymous with genius. His contributions to science have fundamentally shaped our understanding of the universe, and his insights continue to inspire new generations of researchers. From the theory of relativity to quantum mechanics, Einstein's work remains at the forefront of scientific inquiry. One of Einstein's most lasting legacies is his theory of relativity, which transformed our understanding of space, time, and gravity. The special theory of relativity, introduced in 1905, posited that the laws of physics are the same for all non-accelerating observers and that the speed of light is constant regardless of the motion of the light source. This theory led to the revolutionary equation E equals mc squared, which describes the equivalence of energy, E, and mass, m, with c representing the speed of light. This relationship demonstrated that a small amount of mass could be converted into a large amount of energy, a principle that underpins both nuclear power and atomic weapons. The general theory of relativity, published in 1915, further expanded on these ideas by describing gravity as a curvature of space-time caused by mass and energy. This theory provided a new framework for understanding the force of gravity, replacing the Newtonian model that had prevailed for centuries. One of the most famous confirmations of general relativity came in 1919, when observations during a solar eclipse showed that light from distant stars was bent by the sun's gravity, as predicted by Einstein's equations. This discovery catapulted Einstein to international fame and solidified his reputation as one of the greatest scientists of all time. Einstein's work also laid the foundation for the development of quantum mechanics, a field that explores the behavior of particles at the smallest scales. His 1905 paper on the photoelectric effect, which described how light can be absorbed by materials in discrete packets called quanta, or photons, provided crucial evidence for the quantum nature of light. This work earned him the Nobel Prize in Physics in 1921 and opened up new avenues of research that would eventually lead to the development of technologies such as lasers and semiconductors. Despite his contributions to quantum mechanics, Einstein was famously skeptical of some of its implications. He particularly objected to the theory's probabilistic nature, encapsulated in his famous quote, "God does not play dice with the universe." This skepticism led to his famous debates with physicist Niels Bohr, one of the key figures in the development of quantum mechanics. These debates, known as the Bohr-Einstein debates, were significant in shaping the philosophical foundations of quantum theory. Einstein's influence extended beyond his scientific achievements. He was a passionate advocate for peace, social justice, and human rights. His outspoken opposition to war and militarism, particularly in the context of World War I and World War II, resonated with many and added to his status as a moral authority. He used his fame to speak out against the rise of fascism and anti-Semitism in Europe, and his decision to emigrate to the United States in 1933 was driven by the growing threat posed by the Nazi regime. In the United States, Einstein continued his advocacy for social causes. He was a vocal supporter of the civil rights movement and worked alongside prominent leaders such as W.E.B. Du Bois and Paul Robeson. He spoke out against racial segregation and discrimination, and his commitment to equality and justice was evident in his public speeches and writings. Einstein's dedication to these causes earned him respect and admiration far beyond the scientific community. Einstein also played a significant role in the development of atomic energy. Although he did not directly work on the Manhattan Project, his famous letter to President Franklin D. Roosevelt in 1939, co-written with physicist Leo Szilard, highlighted the potential for Nazi Germany to develop atomic weapons and urged the United States to accelerate its own research. This letter led to the establishment of the Manhattan Project and ultimately to the development of the atomic bomb. After witnessing the destructive power of nuclear weapons, Einstein became a leading advocate for nuclear disarmament and international control of atomic energy. In his later years, Einstein focused on philosophical and ethical questions, contemplating the implications of his scientific work for humanity. He maintained a deep curiosity and a sense of wonder about the universe, and he continued to engage with scientific and philosophical questions until his death. His reflections on the nature of reality, the limits of human knowledge, and the relationship between science and society have had a lasting impact on how we think about these issues. Einstein's contributions to science and society have left an indelible mark on the world. His theories revolutionized our understanding of the universe, his advocacy advanced social justice, and his enduring curiosity continues to inspire. Albert Einstein truly was a genius of physics, and his legacy will continue to shape the future of science and humanity for generations to come. Key figures of the Einstein era. Niels Bohr. Niels Bohr was a Danish physicist who made foundational contributions to understanding atomic structure and quantum mechanics. Born in 1885, Bohr developed the Bohr model of the atom, which introduced the idea of electrons orbiting the nucleus at specific energy levels. This model helped explain how atoms emit and absorb light, providing a basis for modern atomic physics. Bohr's work earned him the Nobel Prize in Physics in 1922. He was also known for his philosophical debates with Einstein on the nature of quantum mechanics, particularly regarding the probabilistic interpretation of quantum events. Marie Curie. Marie Curie was a pioneering physicist and chemist who conducted groundbreaking research on radioactivity. Born in Poland in 1867, she became the first woman to win a Nobel Prize and remains the only person to have won Nobel Prizes in two different scientific fields, physics in 1903 and chemistry in 1911. Curie's discovery of the elements polonium and radium and her work on the isolation of radioactive isotopes were crucial to the development of atomic physics and cancer treatment. Her research laid the groundwork for the field of nuclear physics and had profound implications for both science and medicine. Max Planck. Max Planck was a German theoretical physicist who is considered the father of quantum theory. Born in 1858, Planck introduced the concept of quantized energy levels, which led to the development of quantum mechanics. In 1900, he proposed that energy is emitted or absorbed in discrete units called quanta, revolutionizing the understanding of atomic and subatomic processes. Planck's work earned him the Nobel Prize in Physics in 1918. He played a significant role in the early development of quantum theory and was a mentor to many of the leading physicists of the time, including Einstein. Werner Heisenberg. Werner Heisenberg was a German physicist who made significant contributions to quantum mechanics. Born in 1901, he is best known for the formulation of the uncertainty principle, which states that the position and momentum of a particle cannot be simultaneously measured with arbitrary precision. This principle has profound implications for the behavior of subatomic particles and the nature of reality. Heisenberg's work in matrix mechanics, a formulation of quantum mechanics, earned him the Nobel Prize in Physics in 1932. His contributions helped shape the modern understanding of quantum theory. Erwin Schrödinger. Erwin Schrödinger was an Austrian physicist who developed the Schrödinger equation, a fundamental equation of quantum mechanics that describes how the quantum state of a physical system changes over time. Born in 1887, Schrödinger's work provided a wave-based interpretation of quantum mechanics, complementing Heisenberg's matrix mechanics. He is also famous for his thought experiment known as Schrödinger's cat, which illustrates the paradoxes and complexities of quantum superposition. Schrödinger's contributions to quantum theory earned him the Nobel Prize in Physics in 1933, shared with Paul Dirac. Paul Dirac. Paul Dirac was an English theoretical physicist known for his contributions to quantum mechanics and quantum electrodynamics. Born in 1902, Dirac formulated the Dirac equation, which describes the behavior of fermions and predicted the existence of antimatter. His work laid the foundation for the field of quantum field theory and had a profound impact on the understanding of particle physics. Dirac shared the Nobel Prize in Physics in 1933 with Erwin Schrödinger for their discoveries in atomic theory. Enrico Fermi. Enrico Fermi was an Italian-American physicist known for his work on nuclear physics and quantum theory. Born in 1901, Fermi made significant contributions to the development of the first nuclear reactor and the understanding of beta decay. He played a key role in the Manhattan Project, which developed the first atomic bombs during World War II. Fermi's research on neutron bombardment led to the discovery of nuclear fission, which has applications in both energy production and weapons development. He was awarded the Nobel Prize in Physics in 1938 for his work on induced radioactivity. Richard Feynman. Richard Feynman was an American theoretical physicist known for his contributions to quantum mechanics, quantum electrodynamics, and particle physics. Born in 1918, Feynman developed the Feynman diagrams, a pictorial representation of particle interactions that has become a standard tool in quantum field theory. He also made significant contributions to the understanding of the behavior of subatomic particles and the development of the path integral formulation of quantum mechanics. Feynman was awarded the Nobel Prize in Physics in 1965, shared with Julian Schwinger and Shinichiro Tomonaga for their work in quantum electrodynamics. J. Robert Oppenheimer. J. Robert Oppenheimer was an American theoretical physicist and the scientific director of the Manhattan Project, the World War II project that developed the first nuclear weapons. Born in 1904, Oppenheimer played a crucial role in the success of the project, overseeing the development and testing of the atomic bomb. After the war, he became a prominent advocate for the peaceful use of atomic energy and served as the chairman of the General Advisory Committee of the Atomic Energy Commission. Oppenheimer's leadership and scientific contributions had a lasting impact on the field of nuclear physics and the development of atomic energy. Lise Meitner. Lise Meitner was an Austrian-Swedish physicist who made groundbreaking contributions to the understanding of nuclear fission. Born in 1878, Meitner collaborated with chemist Otto Hahn in the discovery of nuclear fission, the process by which the nucleus of an atom splits into smaller parts, releasing a large amount of energy. Despite her significant contributions, Meitner was overlooked for the Nobel Prize, which was awarded to Hahn in 1944. Nevertheless, her work laid the foundation for the development of nuclear energy and the atomic bomb. Thank you for joining me on this journey through the key figures of the Einstein era. I hope you found it as enlightening as I did. Stay tuned for more stories from the pages of history.